Good day, ladies and gentlemen. I am Dimples Tinto, one of the presenters from the team Epochs, consists of the proponents Francis Tinao and Lenor Jamero, which will start the discussion by introducing to you our revolutionary application, Artsify, which integrates computer vision and neural transfer with the BGG19 model. To begin with, what is neural transfer? According to the official documentation of TensorFlow, neural transfer is an optimization technique used to take two images, a content image and a style reference image, such as an artwork by a famous painter, and blend them so the output image looks like the content image, but painted in the style of the style reference image. Through this, we can create new art ideas using this technology. Now, what could its purpose be in real life if we apply neural transfer in art? It allows artists to expand their creativity and knowledge, enabling them to generate brilliant ideas and transform them into masterpieces. Through neural transfer, they can manipulate existing artwork to create new, innovative pieces. With this, we could learn more key points of integrating computer vision and neural transfer in art, which consist of 3 points, starting with computer vision in art. Computer vision is a field of artificial intelligence that enables computers to interpret and make decisions based on visual data. In the context of art, computer vision can analyze artistic elements such as color, texture, and style. This analysis provides a foundation for various applications, from art restoration to digital creation. By understanding these elements, computer vision algorithms can assist artists in enhancing their creative processes. Secondly, transforming creativity. Neural transfer, a technique within computer vision, allows for manipulating existing artwork to create new pieces. This process involves using neural networks to extract the style of one image and apply it to the content of another. The result is a unique blend that retains the original content's structural integrity while adapting the chosen artwork's stylistic features. And lastly, expanding artistic horizons. Using neural transfer in art allows artists to expand their creativity and knowledge. By leveraging this technology, artists can experiment with different styles and techniques without the limitations of traditional methods. This experimentation fosters the generation of brilliant ideas, enabling artists to envision and realize concepts that might have been impossible otherwise. With all of the key points being presented, we can now understand the impact of neural transfer in art industry. Now, let's get ahead of the problem solution, which will be discussed by Lenor Jamero.
Now, the main question is, what is the problem that needs to be solved with the use of computer vision and neural transfer? Obviously, as discussed by Ms. Dimples, it is for the artist. Now, why? Glutamate is the most abundant neurotransmitter in your brain. It plays an important role in learning and memory by facilitating the transmission of signals between neurons. This process is essential for synaptic plasticity, the ability of synapses to strengthen or weaken over time, which is foundation for learning and forming memories. In the context of creativity, glutamate is involved in generating new ideas. Promoting neural communication helps the brain synthesize information and create novel concepts. This neurotransmitter is particularly important for artists as it fuels the mental processes required for artistic inspiration and creativity. However, excessive or imbalanced glutamate activity can lead to cognitive overload, which may result in mental struggle to develop fresh ideas or feel creatively exhausted. This state can be attributed to overuse of neural pathways related to creative thinking, leading a temporary inability to produce new and original artwork. How could we address this scientific problem to solve the artist's day-by-day challenges?
Introducing Artsify, a desktop application designed to help artists generate new ideas and abstracts. Utilizing neural transfer and computer vision technologies, Artsify enables artists to create new masterpieces by manipulating and reimagining existing artworks.
Now, how does this application work? First is you have to upload an existing artwork or any image you want to make art with. Next is you have to upload an existing artwork like paintings from the past or in Renaissance period. Next is you have to upload an existing artwork like paintings from the past or in Renaissance period that would serve as the pattern for your image. Third is to run some configuration and tweakings that will work on the backend.
And lastly, to click the Artsify button to generate a new fresh art.
Now, let's delve into the technicalities behind this application and the said technology, which will be discussed by Francis Tinao.
Thank you, Ms. Dimples and Mr. Lenor Jamero for your interest. Now let's delve into the technical aspects powering the Artsify app. Have you ever wondered about the technologies driving this revolutionary application for artists? Well, for the front end, we utilize Electron, a robust framework that employs basic stack like HTML, CSS, and JavaScript to craft a native-like desktop experience across various operating systems. Electron's versatility not only ensures seamless performance but also enables us to integrate modern UI/UX features for an intuitive user experience. Handling the intensive computational tasks required for machine learning. Now we turn to Fast API for our backend framework written in Python. Its asynchronous capabilities and automatic documentation generation streamline development and deployment processes. True to its name, Fast API excels in performance, especially in handling machine learning algorithms and models, making it the ideal choice for our application's backend infrastructure. Lastly, for our neural transfer ML functionality, we relied on PyTorch, a leading machine learning framework known for its flexibility, scalability, and extensive community support. With PyTorch, we can efficiently implement complex neural network architectures, ensuring accurate and highly results for artistic transformations within the Artsify app. What is working behind transformation of the image into new art? Now, ask it yourself. With the Artsify pipeline, as we can see on the diagram, we have two inputs. First input will be the style image and second will be the content image. It will then be fed into the neural transfer architecture. Now, neural transfer architecture is a computational framework that uses neural networks to transfer the style of one image onto the content of another. It involves extracting the style features from a reference image and applying them to a target image, resulting in a new image that combines the target's content with the reference style. This technique has applications in art generation, image stylization, and creative content creation. After feeding it from the model, it will output a new image containing the style that the user uploads from the front end. The generation of the output's duration will depend on what value the number of steps and the style width has. These values come from the front end and will be sent back to the back end. The initial value of the number of steps from the back end is 1000, and the style weight is 100,000. If these values decrease, the generation of output also speeds up. The duration in seconds will vary if the value of both variables increases or decreases. Once it increases, the duration will take time, and once it decreases, it will also speed up the output generation. However, if the style weight and the number of steps are pretty low, the accuracy of the output will also be affected. Hence, the output will be pixelated and far away from the content image. So as you can see in the next slide, and from the results, when we have a higher number of steps and style weight, the subject is clearer and more defined. However, if we have fewer steps and style weight, the style image overpowers the content image. This is how the neural transfer works. A lot of information is being fed up to you right now, right? Well, without further ado, let's check out the demonstration, and after that we'll review the code behind all of what's happening in Artsify. So, let's go! Alright, so here we are in our demonstration and code review. So as you can see, I've already set up the application as our front end and back end are already starting. And the front end. So here I'm going to discuss to you and show you the demonstration of our application and discuss to you the code behind all of the functionalities that's been running in our application. So our app composes of two main directories or root directories, mainly the SRC folder and the API folder. As for the SRC folder, it contains all of the files for our front end, the templates, a TypeScript file, and also for the back end, we have a bunch of files that's been written in Python, which composes of all the functionalities and as well as calling the model for our application. Now, first is I'm going to show you three major components that's built for our application, mainly the upload content image, the TSX, the upload style image, the TSX, the side panel, the TSX. Now, going first to the upload content image, is this component will handle the uploading of our content images. What the file name says, it is upload content image. Now, we have 5 or 6 major functions that will handle all of those functionalities that we can drag and drop image and also select an image from our folder. So as you can see here, we already have our upload image, and we've already uploaded an image, and also we can select another one. So we're going to select let's say this one, as you can see, but we're going to select again this one for a viewer file name. So this is what upload content image functions. Next would be the upload style image. So as you can see, the documentation is complete. If you want to read the project on our GitHub repository, you can check it out and understand easily, since our project is already composed with comprehensive documentation. As for the upload style image, it is somehow the same with the upload content image. What's new here is just the pre-selection of the style images. So I've already set up a 3 for you to choose, but you can also upload the style image whatever you want. Next would be the side panel, where our functions to generate the artwork we're going to call from our backend is. This is where the component is located at for a function which is called Artsify. Now, in the Artsify, it is a asynchronous function since we're going to communicate or interact with our backend. So it will be a asynchronous function. Now, to check the function is we have a try and catch block, so that if ever there is an error that will occur or exist, then we can dismiss the API calling to the backend and we'll redo the actions again. So we have first check if the mode images are selected, or if there are any images that's been uploaded, since the user is required to upload 2 images. One would be for the content image and the other would be for the style image. Now if there is already an image for both content and style, then we're going to append both images on the form data, which is a form data class instantiated in form data class. Next would be the number of steps and style weight. Now if you're ever wondering where this came from, so going back to our front end, this is what the value came from for the number of steps and style weight. This is a configuration for the back end so that we could provide customization of how many number of steps and style weight will our model will go to. So going back to our code, so we're going now to call our API with this endpoint, which is in 127.0.0.1 with a port of 8000, then followed by its root endpoint, which is // followed by the request body and method, which is post, and then append the form data, which consists of all of the images and the configurations we handled to its body. Now after that, we're going to check if the response is successful. If yes, we're going to retrieve the generated image from our model, which is a blob. Then since it is a blob, then we're going to convert it into an object URL, which is by this line of code here. After that, we're going to reveal it on our image loader.tsx, which is our component, which is this one. So after breaking down front end, let's go to our back end, which is the main.py. So as you can see, our API is also written in any documented documentation, rather comprehensive documentation. So if you're going to check our project, it's easy for you to understand where to start, if there are any configurations that you want to do, so you can just read the documentation. As for the backend, so since we have called this endpoint, so it is a synchronous function which has the parameters of request, object, the input image, and style image. So fast forward, we have here reading on the images for both input and style images, and also for the number of steps and style weight, which is came from the backend, and also after that we're going to convert the input image and style image to bytes IO, which we use on IO library, which is this one. Then we're going to resize the image since our model is required to resize the image or any inputs that's been in an image format, so we're going to resize it. After that, we're going to reprocess the resized image and convert it into tensors. Then we're going to call our runspan transfer, which is the main function to generate an art piece. Then followed by its parameters, CNN normalization mean, normalization, STD, input image tensors, and so on and so forth. After that, we're going to squeeze our image and detach it from our model, feed model. Then we're going, since it is still a tensor, we're going to convert it into a PAL image, which is this one. Then we're going to convert now the PAL image to a byte array by using this function, and then return an image in a streaming response format. Now for the following files, since we've just utilized the lesson 7 Google Colab file, so there's nothing new on this one. It's just from the transfer is, since there are configurations that has been done from the backend, and we are going to accept values from the main root so that our transfer would be dynamic. Depends on what would be the value for number of steps and style weight. And for the pre-process, it's just this one. We're going to resize our images and then convert it into tensor. And this is what I've been talking about, resizing the image, since it requires from the backend, from the model line. So let's try to check. Since we've already had a image, then we're going to upload a style image, just this one, and then we're going to max out the number of steps. Let's just select 600, and for the style weight, we're going to max out the style weight, and let's click Artsify. Let's just wait. There you go. As you can see, we've already generated our output. As what you've observed, since our number of steps is around 600 and our style weight is around 10,000 or 100,000, the generation of the output takes time. So it depends on what value the number of steps has and style weight. Overall, this is how the neural transfer works. So if you want to visit the repository of this project, just visit github.com/kerudafxc/artsify. All of the files has been uploaded there if you want to check out. And that's about it. Thank you so much for listening, and see you around.